Hi, today we will be looking at how to simplify rational expressions. And then to do that, we're going to consider some few examples. So the first example we're going to be considering is going to be 4x squared plus 8x divided by 12x plus 24. Now, to simplify this, there is something which is very important which you need to take into consideration. And then that is, before you carry out any algebraic operation on a rational expression, you must ensure that both the numerator and the denominator has been factorized completely. Now, to carry out that, now what I have here is 4x squared plus 8x, and then what's common to the two of them is 4x. Leaving, we'll have 4x in 4x squared, that's going to give us x, plus 4x in 8x is going to give us 2. And then we close that. Divided by, now for the denominator, we have 12 to be common. 12 is common. Leaving 12 in 12x is going to give us x, plus 12 in 24 is going to give us 2. And then we have this. And then what you observe here is x plus 2 is here, x plus 2 is here. So this crosses this. So we are left with 4x divided by 12. But we don't stop here. 4 goes here, 3. So our final answer is going to be x divided by x all over 3. Let's look at one more example. So you have your total to simplify 3 divided by x negative 1 raised to the power 2 x plus 1, then plus 2 divided by x negative 1 times x plus 1 all squared. Now, we want to simplify this whole thing. And now to start simplifying this, the very first thing you want to do is you want to find the LCM of x negative 1 squared times x plus 1 and x negative 1 times x plus 1 all squared. So we want to find the LCM of this. Now to find the LCM of this, the very first thing you need to do is ensure that the polynomials has been factorized completely. But then if you look at this, it has been factorized for us, and then this has also been factorized for us. So that step is gone. The next step is you rewrite either of them. So I'm going to start by writing the left hand polynomial, which is x minus 1 squared times x plus 1. Now when you've done that, highlight each of the polynomials, each of the terms in the remaining polynomial. So we have a term here, we have a term here. Now the next thing you do is you begin to compare each of these terms with what we have left. If it has a twin, then what you need to do is you retain the one that has the highest degree. But if it does not have a twin, we multiply by the resulting polynomial. Now what we have here is x negative 1. And then we have x negative 1 here. But then the power here is 1 and the power here is 2. So we retain this. We move to the next one. X plus 1, the power here is 2. But here the power here is 1. So we retain the one that has the highest power. So which is this. And then since we do not have any other one, so this is going to be our LCM. So we're going to write our LCM straight up. So we have x negative 1 squared and then x plus 1 squared. So this is our LCM. Then we carry out the whole operation. So this is this divided by this. That is x negative 1 squared times x plus 1 squared divided by x minus 1 squared into x plus 1. So this is going to cross out, and then this will cross out, leaving x plus 1. So we're going to write x plus 1 times 3, then plus, then this divided by this. We're going to have, just following the same procedure, we're going to have x, because x plus 1 squared cancels x plus 1 squared, then x negative 1 cancels x negative 1 squared, leaving x negative 1 times 2. So this is what we have. Then the next thing you want to do is you want to expand what you have at the numerator here. So you have 3 times this, which is 3x plus 3, then plus 2 times x, which is 2x, 2 times negative 1, which is negative 2, then all divided by x negative 1 squared into x plus 1 squared. Then we go ahead to simplify this. So we have 3x plus 2x, which is 5x, and then 3 negative 2, which is plus 1, divided by x negative 1 squared into x plus 1 squared. And then since nothing can cross out anymore, so we have this to be our final answer. So let's look at one more example before we call it quits on this topic here. So the last example we're going to be considering is to simplify 4 plus 1 all over x squared divided by 3 minus 1 all over x squared. Now to carry out this operation here, what we'd observe here is this could be written as 4 divided by 1, and then this could be written as 3 divided by 1. So this is going to give us, now if you're considering the top, when we find the LCM of 1 and x squared, the LCM is x squared. Now x squared divided by 1 is x squared, that is x squared, times 4, then plus x squared divided by x squared, that's 1, times 1, that is 1. Then all divided by, when we find the LCM of 1 and x squared, we would have x squared. Now x squared divided by 1, that's x squared times 3, that is 3x squared. Then minus x squared divided by x squared is 1 times negative 1, so we have this. So when we simplify this, so 4 times x squared is 4x squared plus 1 divided by x squared, then all divided by, maybe I should write this with this sign here, 3x squared negative 1 divided by x squared. Now before we go on further, there's something you need to note. Whenever you're told to divide two rational expressions, a all over b divided by c all over d, now this is the same thing as the product of the first times the reciprocal of the second, that's the denominator, that's d all over c. So we have the same thing here. We are finding we are dividing two rational expressions. So this is just going to give us the first 4x squared plus 1 divided by x squared times the reciprocal of the second, so which is x squared divided by 3x squared negative 1. And then when you look closely, x squared here crosses x squared, so what we have is 4x squared plus 1 divided by 3x squared negative 1, and then that completes the problem.